Hello and welcome back to another video. In this problem we're asked, if f of x is equal to brackets of x plus brackets of negative x, show that the limit as x approaches 2 of f of x exists, but it is not equal to f of 2. So to answer this problem, we have to know what do these brackets mean. Well, this is referring to the greatest integer function, which states that this is equal to the greatest integer that is less than or equal to x. So let's calculate it for 2 because we want to show this limit exists, but we also have to know that it's not equal to 2. So f of 2 equals the greatest integer of 2 plus the greatest integer of negative 2. The greatest integer that is less than or equal to 2 is 2, right? Since it's equal. Same thing here. The greatest integer that's less than or equal to negative 2, that's, all the integers that are less than equal to negative 2 are, negative 10, negative 9, negative 8, negative 7, all the way up to negative 2, which it's equal to. And then negative 1 is greater than, so it can't be. So negative 2 itself is the greatest one. 2 minus 2 is 0. We need to show that the limit as x approaches 2 of this function exists. So you do from the right and from the left, and we show that they're equal. So from the right, that's values of x that are very slightly greater than 2. So I think it could be helpful to do 2.001, right? Plus negative 2.001. So this is, values of 2 that are very slightly greater than 2. And it doesn't matter that we're picking 2.001, you just have to pick a number that's very, very close. The greatest integer that is less than or equal to this number is 2. It's only very slightly less, but it's less than this number. The greatest integer that is less than or equal to this number, you might be tempted to say negative 2, but negative 2 is actually slightly larger than this number. We have to go all the way to negative 3 to find the greatest integer that's less than or equal to, right? If you're imagining a number line, negative 2, we're at this point right here, so close. The greatest integer that's less than or equal to this is all the way down here at negative 3, because this is a slight bit greater. So this is 2 minus 3, which is negative 1. Values from the left, we also have to calculate. So that would be 1.999, right, for example, and negative 1.999. The greatest integer that is less than or equal to this is 1, right? That's probably more obvious to see. And again, 1.999 is right here. So the greatest integer less than or equal to that actually is negative 2, because it's slightly larger than it. So it's 1 plus negative 2, 1 minus 2 is negative 1. So we know that the limit as x approaches 2 of f of x equals negative 1, because from the left and the right, it both equals negative 1, but it is not equal to 0, which is the value itself of the function at 2.